Okay. Looks like it's on. Yeah. Where was I yesterday? Let me run the test again. Big test slash code. Yeah. Okay. How do I make something comp time int? Is there anything about this here? No. Non-integer, the return type is that. Okay, what's the error again? Variable of type comp time int must be a const or comp time. How do I make a variable comp time? It places importance on the concept of whether an expression is known at compile time. There are a few different places this concept is used. And these building blocks are used to keep the language small, readable, and powerful. Introducing compile time concept. Yep. It's compile time duck typing. What's that mean? Types are first class citizens. Line 24. So this needs to be, I don't know if it's very readable with the background. Just noticed. Seems fine. I can make the opacity. Should I make it lower or higher? 5 higher. Oops. There, that looks better, maybe. I think it's Control Shift R. Okay. Yep, I think it's pretty readable. Maybe. Well, someone will let me know otherwise. Right, okay, this needs to be compile time known. Why did I make it 1? That makes no sense. Ah, right, that's for the opcode. for the opcode. Right, okay. Instruction size. Okay, yeah, I know why it's... Oops. Because I'm declaring an array of that size, so it needs to be known at compile time. So what do I do? Excuse me. Oh yeah, well, I mean, I could just make it use the index anyways. And what do I return? I return nothing. Okay, so I can return instruction 0 to instruction index. Instruction. Right. Okay, so I know. I'll just fix the size for now. Okay, 128. I guess this to do limit array size to instruction width. Okay, and expected you wait. Yeah. This one is line 31. I think this one is easier. Enum to something. Cast. Int from enum. I think that might be it. Is that it? Why does this need to be compile time? Known. Maybe I can make it use size for now. Yeah. Also fix the use size type. I don't like use size. Don't know why. I know why, but yeah, okay. What am I doing? Switch width. Oh no, it should be switch. Why am I going through? Guess I should also go through width. Okay, yeah, that one. Assert. What is opcode type? Opcode. I think there's one more. Really? That works? I'm quite surprised, to be honest. I didn't think that would. Really? That works? Okay, let me try another number. I don't trust it. Let's say the operand is one. There should be 0. There should be 1. Can't believe that works, really. This is 0. Okay. I'm a bit surprised. Maybe I didn't know what I was doing yesterday. Okay, so what that test passing means is we can now convert instructions into opcode, like basic instructions. I think what we can do right now is take a address and what? Oh fuck. Yeah. So what can we do right now? Okay. Oh, well, to be fair, we only have the translation from what? Taken and can't remember. Really? What the fuck am I doing? we have an opcode instruction and then the operand to act it on. And I think all we do is make the instructions, turn the instructions into bytes so that we can execute them later. Yeah, okay. Now, I would like to fix these things. Or what I can do is have an array of, like, let's say 4,000 elements, and then only use, I don't know. Okay, we'll come back to this. Because I'm thinking as we add more instructions, but no, actually a single array should be enough. But we'd have to keep track of the index. Okay, we'll come back to that one. What have I done so far? I think operand width is compile time known. So how come? I'm a bit curious now. Let me read about comp time. Comp time. What does this phrase mean? It's compile time duck typing. Computer programming duck typing is an application of the duck test. If it walks like a duck and quacks like a duck, then it must be a duck. Fair assumption? Okay. To determine whether an object can be used for a particular purpose with nominative typing. Aha, that's what they mean by typing. I thought it was like typing, like on a keyboard. Feel like an idiot now. An object is given type if it is declared as such, or if a type's association with the object is inferred through mechanisms such as object inheritance. Given type if it has all methods and properties required by that type. Okay, now I get what you mean. So max is a generic function that takes type and AB, and you can use it with any number. Exec types are first-class citizens, can be assigned to variables. Passed as parameters to functions and returned from functions. However, they can only be used in expressions which are known at compile time, which is why the parameter t in the above snippet must be marked with comp time. A comp time parameter means that at the call site, the value must be known at compile time, or it is a compile error. Yeah, so the value must be known at compile time, or it is a compile error. The function definition. Okay. So does that mean to fix this, what I can do is make kind of w. Let me make temp. That temp instruction. So make it a const instruction size. It's going to be temp. And then instead of 128, I still don't know if that's compile time known. Yeah. I don't know why I thought that would work. That's funny. Kind of stupid. I would like to understand this because I do. The reason being, I always it's something I've come across a few times. For example, if you were to introduce another function to the above snippet, we have max. Condition bool. I see. Because the value of condition can't be known till the program runs. I see what you mean. Okay, this is an error because the programmer attempted to pass a value only known at runtime to a function which expects a value at compile time. That's exactly what I've done. Another way to get an error, if you pass a type that violates the type checker when the function is analyzed. Right. This is what it means to have compile time duck typing. So is this error still a compile time error? On the flip side, inside the function definition, with the comptime parameter, the value is known at compile time. This means that we actually could make this work for the bool type if we wanted to. Right, we change the method. Yeah, it's a good point. How can this be known at compile time? This works because Zig implicitly inlines if expressions when the condition is known at compile time, and the compiler guarantees that it will skip the analysis of the branch not taken. This means that the actual function generated for max in this situation looks like this. Fascinating. All the code that dealt with compile time known values is eliminated, and we're left with this. Is actually quite awesome. Because the function now only needs this statement. Everything else gone. That's cool. Compile time variables. There we go. That's what I want to read about. In Zig, the programmer can label variables as comp time. This guarantees that to the compiler that every load and store of the variable is performed at compile time. Any violation of this results in a compile error. This combined with the fact that we can inline loops allows us to write function which is partially evaluated at compile time and partially at runtime. Got a command function which is struct, it's got name and a function. Okay. Got command functions, name one, func one. Okay, there we go. Defined here 2, 3, and none. Yep, they're all the same type. Perform function. So I can make a parameter comp time. prefix character and stop value. I want to try something. Comp time. Don't think this is gonna work. So, okay. Unable to resolve comp time value W. So how can we make the width known at compile time? Get width based on the opcode. So if the opcode is known at time, does that make the width? Alright, let's just try and see what happens. Unable to resolve comp time value. Const instruction is make. Where do I use it? Here. It's interesting. So does that mean if if opcode is comp time known, the width is also comp time known? That's fascinating. And can we know the opcode at comp time? Don't think that's gonna work, but no fucking way. That worked? Why did that work? It was just a guess. Okay, I want to read a little bit more about it. Oh, okay, probably because I saw it here. Perform function takes comp time variable called prefix char and a stop value. Result is initially start value, and we have a comp time variable I equals 0. While I is less than command functions dot len. Okay. Keep increment I if command function of I.name of 0 equals prefix character, right, you call the, okay, so you basically go through all the functions and then execute based on the prefix. The example is a bit contrived because the compile time evaluation component is unnecessary. This code would work fine if it was all done at runtime, but it does end up generating different code. In this example, the function is generated 3 different times for a different value of prefix. Oh, okay. So all 3 variations of the function are created. Okay, one for each prefix. Note that this happens even in debug build. This is not a way to write more optimized code, but it's a way to make sure what should happen at compile time does happen at compile time. This catches more errors and allows expressiveness that in other languages requires macros, generated code, or preprocessor to accomplish. That is cool. I had no idea that that's what it did. Compile time expressions. Before I read that, I just had another idea. Where did it go? 33. Yeah. Guess what I could do is, okay, before I do anything, compile time expressions in Zig. It matters whether a given expression is known at compile time or runtime. Programmer can use comp time expressions to guarantee that the expression will be evaluated at compile time. If this cannot be accomplished, the compiler will emit an error. Extern function exit, no return. Comp time exit. Right. Doesn't, however, make sense that a program could call exit at compile time. So this is a compile error. However, comp time expression does much more than sometimes cause a compile error. Within a comp time expression, all variables are comp time variables. Interesting. All if, while, for, switch expressions are evaluated at compile time or emit a compile time error if this is not possible. comment this out for now. But I do want to understand a bit more. Return and try expressions are invalid unless the function itself is called at return type time. All code with runtime side effects or depending on runtime values emits a compile error. All function calls cause the compiler to interpret the function at compile time, emitting a compile error if the function tries to do something that has global runtime side effects. This means that a programmer can create a function which is called both at compile time and runtime with no modification to the function required. This means that a programmer can create a function which is called with no modification to the function. So would that mean I can call make well, what I was thinking was if I made this comp time none, I'd had to inline the for. Okay, I'm getting sidetracked here, but I will figure this out. Imagine if we had forgotten the base case of the recursive function and tried to run the case. Oh, so you could know it at compile time. Nice. Used an unsigned integer. So we tried to subtract 1 from 0. Yep. What would have happened if we used a signed integer? The compiler is supposed to notice that evaluating this function at compile time took more than 1,000 branches. Thus emits an error and gives up. Thousand to something else. That's good. It's like, that's pretty cool. It's a good indicator. Nice. However, there is a design flaw in the compiler, causing it to stack overflow instead of having the proper behavior here. I'm terribly sorry about that. I hope to get this resolved before the next release. This will say that in comp time. Just curious, that's all. Okay, no, it's still here. Maybe it's fixed. What if we fix the base case but put the wrong value in the expect line? Compile time unreachable. Okay, the assertion failed. Container level. At container level, all expressions are implicitly count time. See, that's why I thought both definition and opcode are compile time known. So when I do a lookup, maybe missing something. That's why I assumed width was compile time known. Maybe I was wrong. What does lookup return? Returns a definition. Yeah, both of the fields are constants. Thought I heard something. I did hear something. Okay. Oh, this makes sense. Interesting. It's still compile time known. I wanted to check array. Type coercion. Keep missing something in arrays. Okay. What I can do is assert instruction index is less than I'll still keep instruction size. Make this expected instruction size. Oh. Then here I'll assert expected instruction size is less than 128. I'll fix these later. For now. Why does it need to be comp time known? That's weird. Variable of type. That I don't get. Oh, hang on. It's a different variable. No, yeah, it's the same one. The only reason I thought it was causing an error was because I was using it to define the size of the array. But that's not it. What makes this a comp time int? Oh, okay, maybe if I give it say u8 u16. Hang on, does that mean I can now use it? Expected instruction size. Yeah, that's what I thought. To do fix this at some point. Okay, that'll do. I got a bit sidetracked today. Yeah, because array sizes have to be known at compile time. Okay, I think we should head back to the virtual machine. Okay, where was I? The smallest compiler. Now that we have a toolbox called code. Can't believe I just spent the last hour. But I like it though. I thought I had fun. I think that's the whole reason I'm building the virtual machine and the compiler, is to get better at Zig. Yeah, so I don't mind. The last hour was good. I think... what do I think? I think the reason I'm building the compiler seems to be doing its work, which is to get better at Zig. Okay. Now that we have a toolbox, geez, there's like more to do in here than code. Does test will pass? Yeah, it does for now. Come back to that. Now that we have a toolbox called code, we can start working on the compiler. Since we want a system that works from end to end as soon as possible, and not a system that can only be turned on once it's feature complete, our goal in this section is to build the smallest possible compiler. We should do only one thing for now: produce two op constant instructions that later cause the VM to correctly load the integers 1 and 2 onto the stack. Yeah. Op constants, as far as I understand, are just stack pointers. Yeah. In order to achieve that, the minimal compiler has to do the following: traverse the AST we pass in, find the AST integer literal nodes, evaluate them by passing them into object or integer objects, add the objects to the constant pool, and finally emit op constant instructions that reference the constants in said pool. Sounds good? Perfect. I'll start by defining compiler and its interface in a new compiler package. Okay. So if I understand, we gotta parse the input. We got to compile the integers in the input, if any. Got a compiler which has got instructions and constants. What is object.object? No idea. What is object? Maybe I missed something. Because I don't have this type. Right. New compiler. Compile. Takes in a node and returns an error. Yeah, okay. Okay, so I'm guessing it'll be saved to the instructions when you run compile. Yeah, that makes sense. Bytecode, right. What is bytecode? Okay, right here. It's a single instruction and constants. Two fields, instructions and constants. Both the internal fields will later be modified by the compile method. Instructions will hold the generated bytecode, and constants is a slice that serves as a constant pool. Okay, gotcha. So I'm guessing object.object can be any. Right, okay. But I bet the thing that caught your eye immediately in the definition we're looking for earlier in the code package, bytecode. There it is, and it doesn't need a lot of explanation. Contains the instruction the compiler generated and the constants the compiler evaluated. That bit I'm a bit worried about, because what does that mean? Bytecode is what will pass to the VM and make assertions about in our compiler test. Speaking of which, the compile method is empty, and we're going to write our first compiler test that tells it what it should do. Okay, we give it an input. Expected constants, the slice of interface 1, 2. Expected instructions, up constant, and 0 and 1. Why make it separately? Alright, because you gotta push both those numbers to the stack first before you can add them. Okay, yeah, makes sense. Why is 0 and 1? I'm very much confused. Why is it 0 and 1? What am I missing? Shouldn't be 1 and 2. Okay, I'll come back to that one. Okay, run compiler tests. What does that do? Right. Program.parse. Okay, that I understand. Okay, and then compiler takes statements as an input. I get that bit. Compiler.bytecode. The fuck? Okay, I'm guessing this will be the current instruction. Maybe. I don't know. Is it a for loop? Yeah, it is. Okay. Oh, the fuck? Why does it parse the program every time? Yeah, okay. That makes sense. Maybe. I am so fucking lost. I will be honest. Test instructions. Expected instructions. I'm guessing this is just a mistake. What he meant was 1 and 2. Because make takes an operand, an opcode and an operand. Why would 0 be an operand? Maybe. It's all like confusing mess. Well, I am the problem, not the book. Right, we test instructions. We test constants. Hang on. Have I misunderstood the whole thing? Actually, this is correct, because up constant is the pointer on the stack. So it should be 0 and 1. Okay. That's clear. Test constants. Right. It doesn't take too long to explain. We take monkey code as input. We pass it, produce an AST, and hand it, to the compiler, and then make assertions about the bytecode the compiler produced. We do that by constructing a compiler test case in which we define the input, which constants we expect in the constant pool, and which instructions we expect the compiler to generate. Then we hand the test slice with the compiler test cases to run compiler tests to run them. Slightly different approach compared to the first book. The reason is that Go 1.9, which introduced t.helper method, which we call, really? What do you call that? Teacher. Oh yeah, here. Okay. Expect, and yeah, then we hand the test slice to run them. Which cool, and allows us to remove duplicated logic in test functions by defining test helpers. Think of it as inlining run test compilers into test integer arithmetic. That in turn allows us to abstract away the common behavior shared by every compiler test we're going to write, which greatly reduces the noise in every test function and the page count of this book. Okay. Bonus, I guess. Now let's talk about the helpers used in run compiler tests. The parse function contains some of the things we built in the first book, the lexer and the parser. Yeah, we hand it a string and get back an AST. Gonna have to add the expression statement, parse expression statement, because otherwise this will not work. Which I can do it quickly. Yep. Then you run the actual. Test instructions. Okay, I'm just seeing a lot of words on the screen and comprehension is pretty low. I think I'm gonna do it tomorrow. I can't. This is. Yeah, getting confused and I'm not fully here. Alright, I'll start again. Yeah, the smallest compiler. I'll do that again tomorrow. And there's a few things missing from the parser. Which I think I would have to add. I'll probably make a to-do list here. To do. One parse expression statements will make it easier to test the compiler. Example 1 plus 2. And the other thing is allow constants thing 2 to allow constants create not too sure about this. I don't have an object for file or type. Let me have a look at. No, there can't be a token. Parser. Okay. To allow constants, add object. Not too sure. So those are the to-dos. I will be doing that tomorrow. I'm feeling lost today. I guess it's just one of those days. To be fair, it's been like that for the last few days. Okay, but fingers crossed tomorrow's gonna be better. Guess I'm just a bit. Nah, I'm not tired. I'm fine. I guess. Yeah, I'm fine. Yeah, I'm gonna continue from here, but before I do that, I'm gonna make sure I have these two before proceeding further. Yeah, these are my to-dos for tomorrow. I think I need these to be able to move forward with the compiler. Wasn't the best stream, but I showed up and I'm here. I think that's a win in my books. All right, I shall see you tomorrow. I'll be back. And thank you for hanging out. Sorry the stream wasn't the best. And I shall see you tomorrow if you're still here. See ya.